All right, thanks for being here at 31st Hawaii iOS Developer Meetup. Turn out some music. And so the quote of the week is, the only way to do great work is to love what you do. If you haven't found it yet, keep looking, don't settle. Steve Jobs. We've got some upcoming meetups on July 27th. We've got Firebase real-time database. I've already done the code for it, super stoked, super easy, just really happy about Firebase. On August 3rd, we're going to be covering ARKit, and that's when we're going to be at the iLab. And then on August 10th, we're going to be covering Architecture 101 with Adam Smith. That's coming up. Pro tip for this week is kind of just like, if you're using a ton of programs, I didn't know how to do this, is like hide all the other programs besides Xcode. And in order to do that, you can just do a Option Command H, hide all other applications, make the current app the only one shown. I'll blast through the housekeeping. This is the Hawaii iOS Developer Meetup. If you're going to communicate, please keep it on the Meetup page. We are very lucky to be here at HICapacity. If you're interested in becoming a member, you can go to hicapacity.org/membership. And we've all been here. Bathrooms outside to the right, keys on the black lanyard by the door. We use Spectacle app and Screen Hero. They're great. Tonight, Ryan is going to be talking about threads in Swift. But before we get into that, let's just do quick introductions. Does anyone want to go first?
So I'll go ahead and introduce myself.
Okay.
So let's see. I'm originally from North Carolina, and I've been living in Honolulu now for about 2 years. And I work at a company that does primarily Java and JavaScript development. So Swift is entirely in my free time. I've been developing in Swift now for maybe like 8 or 9 months, and I have to say I've been pretty happy with Swift. Like it's a pretty solid language from everything I've done so far. So that's kind of it.
Cool. That's right. Anybody else want to go next?
Okay, I'm Jay. I'm an app developer for my company EcoCube. And the product itself, it was written in Swift from the very beginning, from Swift 1 to Swift 3.2 and 4. I was looking for some of the features in 4, particularly the serialization. But I'm happy with the language, and the beautiful part about the whole app itself, the engine itself, is you basically platform independent. So when at some point, well, I'm going to port the code into Linux at some point.
Cool. Let's read your check.
Sure.
Thanks. I'm Neil. Here for about 2 years also. Currently, I'm just like playing around with a couple of audio languages, and I'm trying to replicate what I can do in that inside AudioKit. So see if I can do that within either iOS or Mac. So I'm testing out Chalk. It's a music programming language developed at Stanford. There's also, oh man, I get horrible memory. I'm all here. Yeah, there's like 5 different ones, pure data and all the ones, and I'm trying to mess around with them, see what they can do, and see if I can replicate that in AudioKit. Just kind of like testing all the capabilities of AudioKit. Yeah. What a good week.
Right on. So read here. Tyler?
Oh, hi, I'm Tyler. I'm just studying Swift as a hobby right now because I don't have a Mac, so I can't really do much. But hoping to get a Mac soon.
Oh, right on. Cool. Thanks for reading time. I'm David, organizer from this valley, Manoa. I love Swift programming because it's so clean. So I haven't had too much experience with threads, so I'm happy to be here for this session.
Cool.
Okay, so I think that's all the introductions, and the floor is yours, Ryan.
Awesome. All right, so I guess kind of the reason why I decided to go with threads was that in my app, I ended up kind of being forced to use threads, and just very simple kind of rudimentary stuff, but I was actually pretty blown away by how easy it was to get going with threads in Swift. So from the outside, I feel like, I was thinking about this when I was kind of typing some of the stuff last night. I was like, man, threads is kind of a boring topic. But when you think about it from the perspective of like somebody who has done threads in another language, or just someone who really needs kind of some performance focus on their Swift app, like it's actually pretty cool what you can do inside of Swift. So that's kind of why I went down this path. And to do the talk today, I kind of prepared using actually 3 tutorials online. And one little piece kind of from the Hacking with macOS, I think is the name of the book. It's one of the Hacking with series, which is good. I guess I have the links for all 3 tutorials. So all of this is kind of a mishmash of these things. I'll just kind of mention real quick. I did the Ray Wenderlich, I think is how you pronounce it. I would actually recommend going to this one first, and it's the top Google result if you look for threads in Swift. I think it is. So this one is a little bit more complicated than what I'm going to show, but it goes through some really good kind of gory detail about threads. So it's my top recommendation. And then I have I have a sample app that I pulled from this one that I'm going to go through a little bit. And it's really simple, so it'll be kind of just like a starting point for where we're going. And then from this one, this has some pretty interesting stuff that I could fit all into a playground. So we'll do kind of some nice take a look at what's really going on with some of our thread execution, or what's going on with our queues, just inside of a playground, which is actually pretty nice to look at it from that perspective. So I'll minimize this, but I'll probably refer back to some of these just for some of the images, because it's kind of nice to have some of these images to refer to when it goes into some of the details, because a lot of this stuff is not really like code heavy, which is awesome, right? Like that's kind of the cool thing about it, is that you can do a lot with threading with a really small amount of code in Swift. So a good bit of it is actually kind of theoretical. So we'll kind of jump back and forth a little bit. But so I guess that's kind of the intro to it, and the start of this is why and when should you even use threads? Like what is this point where you're like, hey, I actually need to use a thread when you're writing something kind of like simple as an app. So in my case, I'm writing an app that basically uses a lot of raw user input, and it turns out that it was really nice to shift the detection of connection of devices, like say a Magic Mouse or another Magic Trackpad. You might have to have your application listening for that kind of stuff. So why would you have your main thread listen for connections of devices or listen to trackpad input when you could have another thread doing tasks like that for you, right? So that's why I went down that path. But in iOS development, typically you'll kind of come across this type of thing in a different way. And most of the time, do you have anything, Che?
Yeah, basically, when you have to use threads, and it's especially when you're dealing with concurrent programming, especially with network requests where you want to, or loading a file or something. That's one of the places where you really want to put that in a time-consuming task that you really want to put that in a different thread.
Yeah.
And not block the main thread for that.
Yep.
Like network connections, particular.
Exactly. So that's kind of like number one, is one of the first things that you'd want to think about putting in a separate thread.
Yeah.
And what kind of rule number one I think of is that basically you just want to keep the main thread is the thing that's running your UI. You want to keep that free so that it's really just focused on having a really responsive, like really quick, snappy UI that isn't bogged down with doing other tasks. It's just bogged down with interacting with the user. So I have just kind of a first, like I said, like an example app from this one tutorial that just kind of demonstrates that. So I'll just go ahead and pull that up because it's kind of easier to talk to code than talking without it. So this is pretty straightforward, pretty simple. All this app does is just displays pictures of cats that it downloads from these addresses that you see here. So I picked this specific one because it was so simple. So I'll actually go ahead and run it. This is without any threading optimization or any GCD. GCD referring to Grand Central Dispatch.
Yeah. not the greatest common denominator.
Yeah.
Exactly.
Which I keep thinking, yeah, I think that every time I say it or read it. Okay, so let me actually just give this one more run with it up, because it's kind of a subtle thing that because it's not like crazy processor intensive, right? So we're not gonna see a huge lag in what's going on.
Unless you do hundreds of images.
Yeah, so you did actually notice there where all of these images were loaded at once. Hey, welcome.
How's it going?
Pretty good. So what happened is the requests for going out to get these images were all blocking the main thread, essentially. So the main thread's sitting there, and then all of a sudden all the images are displayed at once all these downloads finish. So that's kind of one of those telltale signs, maybe, where it's like, hey, you know, maybe I need to spin this off on the background thread because it could take a while. So say that I had a ton of images on here and I had some scrolling, then you might end up seeing that like it's really choppy scrolling because it's sitting there trying to load all these images. So there's some really simple stuff that you can do, and I put this into a separate function just for loading that. We can look at kind of the comparison between these two, and that'll give us a good starting point as to what we can do. So you can actually just ignore that comment, and we'll just look at these two lines. So here we're just obtaining the images based on URL. So we're literally just grabbing data from this URL, and then we're assigning it to the image. So it's pretty straightforward. There's not a lot going on there. And if we kind of just take away all these comments here, this is our more asynchronous way of doing this. So this is using Grand Central Dispatch to load these asynchronously. So it's pretty straightforward, and we'll kind of dive into just the terminology of what this is actually doing. But these two lines are the same, so these are still there. We're just deciding to run these on different threads, essentially, by using the Grand Central Dispatch. So we have one that's calling an async on global, and I'll get into that a little bit more in a little more detail. So this one is actually running this code asynchronously on a different thread than the main thread. So this is what's actually grabbing our data from the internet. And then now we're going back to the main queue, so the main thread essentially, where we update the UI, and then we actually call this just to update the UI there. So it's pretty straightforward stuff, and the reason why we want to go back to the main thread is because all of our UI work has to be done on the main thread. So essentially AppKit is not multi-threaded. It's single-threaded, and you want to go back to that thread when you're wanting to update the UI. Otherwise, it's not necessarily going to catch that there's an update, and you will actually get some errors from Swift at runtime if you decide if you try running updating the UI from a non-main thread. So
It's also
sure.
UIKit is also single-threaded and not thread-safe, so the Apple warned you not to do any UI on a separate thread. Makes sense.
Yeah, so kind of diving into a little bit more of what you see here. So we're going out and we're grabbing different the global queue. So we actually have a few options that are built into Grand Central Dispatch, and you'll notice that this is all queues, right? So we're dealing with queues, not threads, essentially. There's kind of some fine line on the terminology there, where we are inherently dealing with threads, but we're getting there by using Grand Central Dispatch queues. And the cool thing about this is it makes it so much easier to not make mistakes as a developer when you're just dealing with queues as opposed to dealing with threads. I don't know if any of you guys have had to deal with like thread pools or anything in Java, or
I heard it's not fun, even in Java.
Yeah, so it's a challenging thing, and it's one of the many headaches that you get when you start going down the concurrency path. So really pretty awesome to have that entire thing alleviated where you don't really think about it, because Grand Central Dispatch is essentially it's managing the thread pools for you.
Exactly.
So you kind of just, you're basically giving it things that you want it to do, and then it's deciding, okay, I've got this thread pool, I'm gonna run it on this thread. And we set it up in a queue kind of structure. So that's kind of the cool part about it. So kind of mentioned that UI changes are all done on the main thread, so that's all on the main queue. There's 3 different types of queues. We see in this code that we have example of 2 of those types. So we have the main queue is basically running on the main thread, and that's a serial queue. When you think of it as in terms of serial versus concurrent, and I'll go into some detail about that too. Yeah. Okay. So we also have the global queue, and these are basically queues that they're concurrent instead of serial, and they're all shared by the system. And then you could also make your own queues too. Yeah. And we'll see some examples of that later as well. And your own queues can be serial or concurrent. So I'll actually pull up one of the tutorial pages, and we can kind of look at serial versus concurrent. So serial, of course, as you'd expect, is running things one at a time, whereas concurrent means that there could be multiple things running at the same time. So in a queue, you're not necessarily guaranteed to know how many threads are running inside of that queue. So you could actually end up with a scenario like this where you have a couple of these things running on different queues or different threads, but they're all inside of this queue. So it can get a little confusing, but the nice thing is that that's all abstracted for you. You really don't care about this too much until you get into some more really nitty-gritty kind of management of this type of stuff in terms of, are you really looking to get data back out of this queue after you've executed it? In the case of this sample application, right? This is stuff that's coming back to the user afterwards. So it's a little different, it's a little simpler. So it's kind of like low-hanging fruit in terms of stuff that you could do, because you're not having other pieces of code relying on stuff that's run asynchronously, if that makes sense. Yeah. So you're actually, the end user is the person that's taking things in, multiple at a time, which I'll actually go ahead and we can just demo what this looks like. So commenting out the sync, and we'll run that. Yeah, so it's kind of subtle just because it's not a ton of images that we're loading, but it actually, to me, it does, like, this really simple kind of silly app actually does feel a lot snappier when you see the loading stuff up front, and then you get all of your images later. So if I was actually writing this in kind of a more serious way, I might end up using completion handlers in conjunction with this. So you'd be dispatching things to other threads, and then you'd pass in essentially a closure that would get called when this thing finishes. Yep.
In fact, a lot of the APIs, like with UIKit, have a lot of completion handlers in case you're doing things asynchronously.
Is that the role of a completion handler? Is an asynchronous call being finished?
Exactly.
Gotcha. Yep. Yeah, so I think of those usually more as like a callback.
Yes, like that's what they are. Callbacks.
That's the common term for it. I don't know.
No, that is. But the problem with that is that you can end up having nested callbacks. Hence the phrase callback hell.
Yeah, which is, if you're a JavaScript developer, you're used to that. You've experienced that most likely.
That's why they have futures and promises. In fact, I'm looking at one of the promise libraries written in Swift to deal with that nested callback hell.
Yeah. For sure.
Especially with networking, because of ping.
So we've kind of mentioned now that we have these 3 types of queues, and here's some examples here. One of the other things that I kind of glossed over that I didn't touch on is that you'll notice that this is actually trailing closure syntax.
Yeah.
So this async is actually a function being called, and then this closure is the argument to it.
Yeah.
So it actually makes, this is one of those
easier to read.
scenarios where the trailing closure is actually significantly easier to read. You have
Yes.
a lot less braces,
Yes.
right? And this is kind of a common pattern, unless like if you're doing the completion handler, this will probably look kind of different, but a pretty common pattern, provided we go this like low-hanging fruit route of kind of picking off these things that are coming back to the UI, is actually seeing this, where we kick off something on a background thread,
Yep.
and then we basically, inside of that closure, we're going back to the main thread to update. This is kind of just like a common thing to see if you're going this route.
So pretty much kind of common pattern of you pulling from like third parties APIs information and.
So they'll probably have third-party APIs will probably have completion handler style ways to do it. So you'd kind of be abstracted away, where you just have essentially like you have this thing that you want to call when it gets done. So,
Okay, and then pretty much with the completion handler, what you control on is when you're showing the data to the user. Pretty much. Okay.
Yeah. So you may or may not have to go back to the main thread in order to do that stuff manual, like yourself, right? Depends on whatever library people have. I honestly haven't used anything that has anything like that. I kind of just glanced through when I was looking at this, and that seemed to be kind of the pattern that I saw. But I'm kind of learning through this too, so
Right.
There might be things that I'm unaware of too. So now that we've kind of seen this, and we've seen a pretty good example of how this works, why don't we kind of pull up the playground and dig through a little bit more of what's going on and what our options are really, because you do have a little bit more things that you can choose from, a little bit more complexity that you can give this, because this is pretty non-complex in terms of options that you actually have.
Right.
So we'll come back to that later. There's one more little example that I have on that. So here's a playground that I grabbed from. It's actually code that I grabbed, but a playground that I grabbed from somewhere else, where typically playgrounds, there's kind of some interesting Grand Central Dispatch stuff going on with playgrounds actually. So they don't run on the main queue, and the reason for that is because it's running inside of Xcode, right? You wouldn't want to have something locking up Xcode's UI that you're writing in a playground.
Exactly.
So it's actually running on a global background thread. I'm not sure what the priority of that is.
Yeah, because you can always set the priority with the quality of service. But
Yep. Yeah, so that's what we'll dig into next.
Yeah.
But that's why we have kind of this extra stuff going into here. So there's it needs indefinite execution because we're running on separate background threads, and those might not finish before the current Grand Central Dispatch queue has finished. So if you're running it without this, then you'll end up getting some error messages that tell you that.
Okay, that line right there.
Yeah.
Allows you to
have asynchronous stuff running inside your playground.
Oh,
Yep.
current needs indefinite. Okay.
Yeah, and then at the end of it, you have to tell it that it's done. So then you actually have the play button, the run button, or execute playground.
Where did you get the code here for?
So this stuff, the needs indefinite execution, I grabbed from a video on the Ray Wenderlich. So there's a video that goes along with this.
Right.
There's 2 videos that are free, and those are the ones that I watched. And then the rest of them I didn't watch because you have to pay for them. But these were good, so I'd recommend them. And if you start going down kind of more in depth, I wouldn't hesitate to watch these as well, because the intro was good, and that's where I got the idea to keep these.
Right.
Yeah. So like Che alluded to, you can actually set priority on all these queues.
Yeah.
So
it's in the documentation.
So you can actually say, like, I've got 2 queues that are running, and this one I'd rather have this one finish before the other one does.
And that was how you use quality of service?
Yeah.
You guys used that term before?
Yep.
Yes.
Okay.
I think it was.
It's basically priority.
Yeah, basically.
Okay.
I think it was introduced since couple of years ago. Yeah, it's been around. GCD for a while. I think it was released probably a couple of years ago that they did QoS too. Make things a little simpler.
Yeah. So this is actually kind of a nice thing too, because like if you're in something like Java, then you have to do a lot of work to get kind of this type of priority on queuing up threads and everything. So here,
only, I'm sorry, excuse me. Is it only for playgrounds, or this quality of service is just
this
for
is GCD. This is the API.
Yep.
This is the API related.
Yeah, so all of this code that's inside of my playground can, aside from this playground support stuff, all this code can be used anywhere. Used in an app, whatever you want to write. So kind of a different thing here that we're doing is we're actually using these custom queues for this example here. Actually, I think I do that for all of these examples. And I can talk about a little bit about, why would you use custom queues over using a global queue, or kind of when do you want to use these things? I mentioned, I mentioned that the main queue, like you really wanted to reserve that only for running the UI stuff, right?
Yeah.
So the global queue, you saw me using that in the app, and that's kind of I feel like you almost want to start doing that until you get to kind of, if you have some kind of hairy stuff that's more complicated, then you might want to switch to a custom queue.
Yeah.
So, sorry to interrupt, but your function queues with QoS example, the line right before that, Q1, that's you explicitly setting a custom queue.
That's correct.
Okay.
Yep.
And then these enumerations at the end, user initiated and utility. Have you written those enumerations?
I have not. That's part of the library.
That's part of no. Those are already built into the API.
Yep. So you have these four. There's technically more than that.
Yes, there's also the main, but don't use that one.
Yeah, so the main is the, let's see. So main is the queue.
Yeah.
But you can set these things on non-main, like not on the main queue.
Exactly.
You can set them on the global or custom queues. So this is just basically gives it a priority, saying like, hey, run this one before running this one. So we can actually give that a whirl with this.
Yeah.
So we pull that up. You can kind of see a little bit of interesting behavior here, right? So even though something is a higher priority, it's still running asynchronously.
Yep.
So that's why you end up it'll hit this first one, the red one first, and then since it's asynchronous, this is going in the background, and then you'd hit this one. But you can see that user initiated is a higher priority. So user initiated is kind of high priority.
Yep.
So user interactive and user initiated are kind of interesting terms that they would pick. But this you just see that since user initiated is higher than utility, then this basically gets higher priority just by the operating system.
Yeah.
So this isn't like nothing's guaranteed, but like that's going to be put into a higher priority queue.
So we change user initiated to interactive.
Sure.
What happens
So
if
user interactive would be the same.
Yeah. What happens
You
if
can give that a go.
What happens, however, what happens if you do both be user initiated or with the same priority?
Yeah, we'll give that a go too.
It's still there. It still had at least like 2 blues in there.
Yep.
But if you keep it like that and you change Q1 to sync instead of async, will it push everything first?
Yeah.
All the red ones?
So yeah, so we'll go ahead and do that. There you go.
Yeah.
So
then it's treating it as a, you need to get this first serialized, and then it takes care of everything else.
yeah, which is also kind of a weird thing too, right? Like you could have this just be executing. Let's see how that looks, right? So that's the same in that sense in this situation, but I'll talk a little bit more about this later too. Like like why would you pick sync, right?
Yeah.
Why wouldn't you just run it?
There are cases where you do need. There's certain operations that need to run in sync, and that's when you use sync. But you got to be kind of careful when you're doing it on the main queue, because it's easy to get into a deadlock situation.
Yeah. So that's kind of the caveat with it is typically for most like low hanging fruit types of scenarios, you're always just going to be doing async, right? Because you're not like in the terms of UI. Like if you're pushing stuff to the UI, then it's always going to be
Asynchronous.
Yeah, asynchronous, and the user's going to see it asynchronously. So if you end up with scenarios where you have, say, like this chunk of code running, and then you're going to wait until this other chunk of code running is done before you can process the results together, say, then you're going to have to do some work with sync, because then you're going to have to essentially stop this thing and say, we need to wait until this other piece of code is done executing before we can do this. So then you have things that are in sync and things that are asynchronous as well.
Yeah.
So that's where it gets kind of confusing. Like that's a little bit beyond the scope of what I'll go into tonight.
Yeah.
But there's a lot more that you have to consider there, which is why, because then you could end up with things where
race conditions and deadlock.
race conditions, deadlocks. So a deadlock meaning that you have essentially two threads that are waiting on each other to finish. So then you just end up with none of them doing anything.
Exactly.
Yeah.
Okay.
So that's like
You're
sometimes
stuck.
it's pretty easy to do that unless you're careful as to what you're doing. So the Ray Wenderlich one has a pretty good example of how to proof some code to make sure that it doesn't fall into those kinds of scenarios.
Mm-hmm.
But hopefully you don't have to do too much of that stuff on apps, because I don't know, I guess unless your app is like Chase where you're crunching just absurd amounts of data.
Exactly. Now at this point,
Yeah.
I mean, actually, there's a new feature in GCD which allows you to do parallel forwards. In fact, you can do things not just concurrently but in parallel.
Mm-hmm.
I could use that because of the number crunching, because I'm doing computations with several objects simultaneously. But I'm trying to find it where it is.
Yeah, so I actually had another example in here of async versus sync, but I'll just delete that because we just already went through some of that.
Mm-hmm.
So
I like the multiprocessing part.
yeah, so it's kind of nice to actually see what's going on. That's why I liked this example on the playground.
Mm-hmm.
Is just to actually visually see, it's processing this thing using this queue.
Mm-hmm.
Yeah, so let's see. So there we kind of covered QoS. There's actually a couple more of these, so you could go without one specified, and that works fine too. We did that with the global one.
Yep.
What does it default to?
So I think it's just called default, and that leaves a little bit more liberty to like your operating system to pick that, or GCD to pick it.
Exactly.
So user interactive is kind of like the thing that you basically want to use if it's stuff that's dealing with the user.
Yeah. Any UI stuff.
Yeah. User initiated is also any UI stuff, except maybe it's just you have something else that's just like slightly higher priority.
Yeah.
Right. So that's why I feel like those are kind of weird, because it's kind of like, when do I pick? I feel like I would almost always rather pick user interactive for almost everything, but it gives you just one extra layer, I guess, of priority. So utility is things that you'd probably see like a progress bar for.
Yeah,
like,
like
hey, we're loading this file.
Yeah, if you're loading
like
file transfer operations are usually quite slow, so you want to put that in either the utility or background.
Mm-hmm. Yeah, so
Mostly
background is mostly things that users just not aware that this is happening.
Yeah, like some of the processing, like if you're trying to save something big, you want to do that in the background. And asynchronous.
Yeah, so I kind of mentioned about like having the serial queues versus concurrent queues. So the global ones are concurrent, and the main one is serial, and then custom we could have either one. So we could actually specify here. You can see I'm specifying that this custom one is concurrent. So basically you have all this stuff, and we can look and see what this looks like. Right. So all this stuff is happening concurrently. So it's basically up to GCD to pick when all this stuff is running. But it's going to try to cram through all of it. It's not going to do things synchronously.
Does this have to do with what Che said about parallel execution, or is it a different thing?
It's different.
So,
Okay.
yeah,
This is concurrent, not parallel.
yeah. So there's actually some pretty good stuff on these. Let's see, pretty good pictures of things that are. This one's
Okay.
easy to think through, I guess.
Yep.
So concurrency, right? You basically have this one thread
Right.
that's processing two different things. So there's like a context switch going on there between
Okay.
each person. So this person goes there, gets a Coke, then this person.
Exactly.
So whereas parallel is where you actually have basically this example has like two threads of machines, right? So these are literally happening at the same time, whereas this is context switching.
Yep.
So it's kind of how is it making the most out of your threads?
Okay. Most of it is. Most concurrent apps are doing context switching anyways.
Yeah.
Parallel, you're actually using the syntax as the same. And certain processes can be parallelized, but determining that sometimes is not always easy.
Mm-hmm.
And just to kind of belabor the point, maybe to death, but
Sure.
so each
Go
of
for it.
those is so you mentioned that each of those is a thread, like the red right there.
Yeah.
So the
Yeah.
parallel
Better
one, does that
picture.
require like multiple cores? Is that kind of what we're talking about, or is it a different thing?
Basically, yes.
Okay.
Basically,
gotcha.
you're utilizing both cores to process the thing at the
No
same time.
context switch. It's just like
Yeah.
Yep.
Gotcha.
Exactly.
Okay, that
Yeah.
makes sense.
So I kind of like this picture a little better.
Yeah.
Actually, because then you can see the gaps.
Yeah,
'Cause
the
this-
gaps.
Yeah.
Okay.
So this is like one core. This is two cores.
Just like fast switching, yeah, between like different things that it's doing, and then
Mm-hmm.
coming back down to like one, I don't know, function or whatever it's calling it, just returning to that one single one.
Yeah.
While parallel could be like two different functions working at the same time, they're like completely different calculations.
Yep.
And I also really like the last sentence there, that parallelism requires concurrency, but concurrency does not guarantee parallelism. It is so
Yeah.
true, because parallelism, there's other things. Because in parallelism, you cannot have context switching. Concurrency alone does not guarantee, because it is possible for context switching to happen.
Mm-hmm.
In other words, you got to structure your data so you can do these things in parallel. And recently, GCD has some few new features that allow parallel, like a parallel for loop. I saw that at one of the WWDC videos.
Yeah. I've got one more pretty interesting one here. Let me comment out this guy. So this is going away from the dots, but this is one that I didn't actually see in any of the tutorials that I had, but it was inside of that Hacking with macOS book that I found pretty cool. So are you guys all aware of calculating Fibonacci numbers? So
Wouldn't do it recursively. I'd probably do a memoization
yeah.
to prevent what you call a stack overflow,
Yep.
because it's easy to do that.
Yes. So it's basically the reason why even having this here is I've actually seen Fibonacci used for benchmarking sometimes.
Yeah.
So it's basically just, you know, how much can this processor crunch through this
Yes.
chunk of code.
Right.
So it's like what you're doing is basically generating numbers in this sequence,
Mm-hmm.
and the higher you go, the like exponentially more processing it takes to get these numbers.
Exactly.
So this is kind of a cool example because it's taking, you know, this computation heavy process,
Right.
and we're throwing more threads at it basically, but we're telling GCD to do it for us, which is pretty awesome because we're basically just using one function from dispatch queue. So concurrent perform, and it will go through, basically you tell it how many iterations to do of this block that you're passing it,
Mm-hmm.
and it'll go through and do all that concurrently for you, meaning it takes liberties and uses its uses whatever threads or queues it wants to use to do it.
Right.
So I have basically we can set it to use GCD or not. So we will go without it first, and see how long that takes. Hopefully not too long. It's calculating up to 24. When I ran it before, I didn't have as much stuff going on, so
Also, yeah,
we
that
might
could help.
We might bump the number down a little bit.
Nah, just let it go.
There we go.
Okay, so it took 25 seconds,
Without
or
the
24.3
okay.
seconds. So let's see what it does when we use GCD. Better be faster.
Or will it?
Blame it on GCD.
It wasn't me, it was GCD. 15.5.
A little bit faster.
So that's pretty good. The guy that wrote the book said typically you get around 2 times speed improvement just from doing that. So this is, this is crunching on essentially the stuff that we give it. So
Actually, what would make this faster is instead of what would make this faster? Doing it iteratively.
mhm.
Because of recursion, you have to go through the stack and stuff like that. That
Yeah.
reduces performance.
Yep. And that's kind of I think the reason why it's chosen for this is just to have something that sucks at performance.
Mm-hmm.
see if it gets improved without doing what rightfully should be done.
But the thing is, if you what I would have done, do that and use that technique as well as memoization, and plus some parallelism, be great.
I'm
Yeah.
unfamiliar. I'm sorry to interrupt, but I'm unfamiliar with memoization. Could you just what is that?
Oh, it's a way of it's basically a way of storing your values in a then table. After you compute it, store it again so that you don't have to recompute the
Oh, okay.
values.
So that's the silly thing about this is that when we're going about this specific algorithm, the way that it's written is that we're going through and calculating every single number up until that next one every time.
Mm-hmm.
So
okay.
we calculate 0, 1, 2, whatever. Up
It
until
doesn't
it's-
save that computation. It just does it again.
Yeah.
Which is dumb, right?
Yeah.
Which is dumb. So what memoization does is after you compute that first value, you store it in a table, and then you just keep on storing the base. That greatly reduces the.
Mhm.
It's like a cache. Think of it as
Yeah.
it's a cache. But there are certain kind of algorithms that you can't do it, especially if it generates infinite results.
Yeah.
So your mileage will vary on what you're computing.
Yeah. I feel like the Fibonacci is always like
Definitely.
an interview prep kind of question, because it's like, how would you speed this up? So you got to think of things like that.
It's a form of
In which case we just say use dispatch queue.concurrent-perform.
I would probably do a combination of memoization plus that.
Yeah, for sure. So that's kind of it for the playground. I can also send out the playground because it's slightly different from where I grabbed it from, which is this guy's thing. He did it basically all in an app, but he goes into a little bit more detail on certain things if you want to check that out, if you're more interested in kind of the nitty-gritty of what's going on with these.
I'd love to have a copy of that playground and share it with everyone.
Yeah, because it's super easy to see what's going on.
Yeah, especially with that line you have for concurrent execution inside of the playground.
Yeah, good to have. So let's see, go back to my agenda and see what else got on here. Oh yeah, so I was going to talk about kind of when you would choose to use these different queues, right? And kind of, mentioned that the benefit, or kind of alluded to that the benefit of the custom one is that you could pick serial or concurrent, whereas global you're kind of always stuck with concurrent. So the custom one with serial is basically when you're going to want to be using the sync function. So that's kind of when you would want to do that. An interesting gotcha that is from the video tutorial on the Ray Wunderlich was that you actually don't want to call sync on the main queue because it will force a deadlock. So and just thinking through that, it's kind of interesting. So what you'd be doing is basically you would be calling sync, so then it would not do anything else, it would just go off onto this thread, and then typically the main thread is waiting for you to return to it, but there's kind of like a deadlock happening where the thread that you're running synchronously doesn't know to give the main thread back what it wants when it goes back, which I kind of butchered the explanation of that, but it's interesting that would cause a deadlock. So let's see, so using, like, kind of covered using async on each of these queues, and then using sync is basically, you'd use these things called dispatch barriers, which is kind of synchronizing code, essentially.
Sorry, could we dwell on that for a bit? I like the terminology. Sure. I don't understand what it means. Dispatch barrier.
So dispatch barrier is actually something I didn't see up until going through this either. But you kind of have a barrier task that's sitting between other tasks that are running.
Okay.
So is it fair to say that the barrier task would interrupt asynchronous code to do something synchronously and then give back priority to the asynchronous code?
That could be something it's used for, yeah. It looks like in their example, it's basically like you have something that finishes and then you have something that blocks until you want to run something else.
Yeah, so that you don't execute other tasks. And in fact, there's one area where you have to deal with synchronization and with these barrier tasks. I know is with low-level programming, particularly with Metal, where those things with the syncing will become very important.
Right.
Because I was just reading through this stuff because it's very parallel. The Metal API is very parallel and uses a lot of the stuff here. And that's when you're doing graphics programming, you gotta be careful in the order. So you have to do a lot of syncing as well.
Mm-hmm.
So.
Yeah, so again, this is something that I haven't dug into too much too. So I'm not a authoritative, source of information for it.
I love that terminology. Dispatch barriers.
Yeah, I know.
And in those videos, like the WWDCs, when they introduce it, they give the rationale why they added some of those features to avoid certain conditions.
Yeah, so kind of one last bit of code that I wanted to share was doing an async delay. So a lot of times in an app, it's kind of frowned upon to be delaying and waiting on other things, right? But there's certain scenarios where it actually makes perfect sense that you'd want to do that. And one such scenario that I saw in a demo, I think it's actually part of this one, that was pretty good, is when you'd want to have essentially like a pop-up message come up to the user if they kind of sit there and don't do anything for a little while when they first open your app. So maybe you want to just give them kind of like a glimpse of the UI before you start trying to tell them what to do. Or say that you have something that you're loading images, but they didn't load any images yet. So it's like a pop that's like, hey, click on this button to load some images now.
Right.
So you might want that. Now I understand. Yeah, you might want that to pop up a little later. Okay. So that's a pretty good example, because otherwise, there's always the bad use cases of adding delays is because it's unreliable. You don't know when things will actually finish. But so I have an example of that, of the good example.
Right, just giving you a heads up. You got 10 minutes left.
Yeah. Thanks. So we have, let's see, added in this little show alert function here. And then here's the async after. So this basically just tells us to run it 2 seconds from now when we get to this. So it's kind of just like a nice additional feature that we have with the dispatch queue. And you can run this straight up on the main queue as well. So we just give it the async after, and go ahead and run that guy.
Which version of Xcode are you running?
I have not updated to the latest one. So you saw it gave us a second to, to see that, and then we got a pop up. So it's kind of like a good feeling UI, right?
Yeah.
To have that kind of behavior.
I like the example you came up with in terms of like if you were trying to like onboard someone. Like this is the app. I want to actually pause the app so I can give you an alert.
Yeah.
Let you know how it's going.
Yeah, it's a little. I don't know. It's just for some reason it feels a little nicer. I guess.
Mm-hmm.
So that's kind of it for the actual code examples that I had for today. Like I said, it's kind of a lot of information and not a super ton of code to go with it. But there is also kind of one last thing that I wanted to mention is that in addition to GCD, there's also a thing called NS operation queue. And I don't know if that's updated with Swift 3, because GCD got updated with Swift 3, and that's why we have kind of as nice a syntax as we have for putting all this stuff in there. But NS operation queue is kind of like an abstraction from GCD. So
I think it's built on GCD.
It is. So then you can basically use kind of like friendlier looking syntax to basically spin up threads, spin up queues in GCD. So it's something that like all the tutorials that I looked at, they all mentioned NS operation queue. GCD is kind of like bare bones and simple for most things, or it's kind of like I almost think of it as like kind of the bare bones simple or the really complicated, where you could have like all of your queues that you're trying to sync up and avoid deadlock and everything. Like you probably want to be using GCD for that when you get to that point. But that kind of in the middle part where you don't want something that's like super simple, but you don't want something that's super complicated, then maybe NS operation queue is kind of the way to go. And the video on Ray Wenderlich, their example that they use, they use the NS operation queue there. So it's kind of interesting to check it out, see how that's different from GCD. But I feel like in my app, I use GCD, and I feel like I'd probably stick with that unless it gets kind of unwieldy. Maybe see what NS operation queue is about. So.
Thanks for putting this together. It was really informative, and I like the structure that you just explained this to us. It seems like I want to stick with GCD, like at the minute, like NS operation queue. Like it seems like you can do everything in GCD.
Yeah, you can do. It's pretty powerful, and it's just so easy to use. Like surprisingly easy to use.
With NS operation queue, it's basically it's a wrapper around GCD. It makes such things easier.
Yeah,
it's a wrapper.
Makes what easier?
It's NS operation queue is it's a wrapper to GCD.
So it kind of just gives you a little bit, like instead of directly saying like, hey, give me dispatch queue.main or dispatch queue.global, you have nicer syntactical sugar of saying.
That's good to me. I like that.
Yeah.
You have things that, like an example would be like, run this thing and then run this thing when this completes.
Okay.
Right.
Like very English, like grammar.
Yeah.
More grammatical.
Yeah. So it's a little bit more fluent in the sense, like it's a little easier to read, but it's a little more verbose at the same time.
Okay.
So it's more like microcontrol. So you're able to control better what runs at like at what time?
No. It's just an abstraction. So it's kind of like just an alternative almost, which is interesting. So we're kind of running out of time, but I can pull up their example.
Like I said,
that has it. Let me see.
So with Swift 3, GCD is a lot easier to use. Before, it was kind of tricky because it used C-style blocks. Takes some getting used to.
Let me see if I can find some of this. I haven't really looked at it, but I know that this example used it.
Oh, nice.
Cool. Yeah, so here's just a little bit of, here they're making an image decompression operation, and then they are basically adding dependencies to it. So like, I think that it's basically, when if this thing depends on something else, then it's going to wait for it to complete. So you can have your operation queue.
Oh, okay, I see.
So yeah, so it adds the operations.
Oh, I see what you mean now.
have
Very
there.
fluid.
Right.
Yeah. So it might be a little easier to read than going the straight GCD route.
Does anyone have any questions for Ryan?
Yeah. Fire away or put them on the meetup.
Yeah, if I could get just some requests, the playground that you shared.
Yeah, great, for sure. Yeah, and the other this app,
What's tilt shift anyways?
that's the sample app from the video, the Ray Wenderlich video.
Oh, I see.
So theirs is kind of the example where the scrolling gets super laggy
Right.
if you're trying to load all these large images and process these images up front.
Right.
So the tilt shift, I guess, is a photography term.
Right.
Yeah.
So
Miniatures.
you're kind of like blurring the corners or the edges.
Right.
So cool.
So this one there, let's see if it's,
Yeah, I see what you're saying.
I think it might be too big of a screen. Yeah, I don't know. So it would load kind of everything in parallel and be kind of nice, but for some reason it's kind of hard to see on this thing.
I see.
So also a good example though. I
Mm-hmm.
got a little bit of info out of this one.
Cool.
Cool. I guess that's all I got.
Thank you so much,
That's
Ryan.
good.
That's
Yeah.
great.
Thanks.
Okay, I'm gonna shut down the stream.
Sure.